Hey guys, Mr. O'Sullivan here. Hey, let's go ahead and pick up on what we were working on today in class. And that was applications of integrals to find the area between curves. So we kind of just sketched out some notes just kind of on the topic to start with and said, okay, we always want to think of area as kind of a positive quantity. And we're going to set that up. We're going to find the area using a definite integral, where our lower bound is kind of our left boundary of our region. Upper bound is going to be the right boundary. And then the top of our region is our function. And in this case, our lower function is really g at x is equal to 0. So we can kind of think of, like we showed in this example, that our integrand is going to be the top boundary minus the lower boundary. So the upper function minus the lower function, or top minus bottom. Okay. So we went ahead and did number one in class, or on the Zoom class. I'm going to skip over the calculator problems for now and then just come back and I'll hit those. So I'm going to do the non-calc problems. So number three, um, the area of the region enclosed by the graph of y equals x squared plus 1 and the line y equals 5. Okay. A lot of times it's easiest, even it's like it's a no calc problem, but I might just sketch these two functions here. So y equals x squared plus 1. It's just going to be parabola. It's just translated. It's going to be this one. Just going to be translated up 1 unit. So it's just going to look like that. So x squared and the plus 1 just moves it up vertically. Okay, and then our other function, y equals 5, is just going to be horizontal line at 5. Okay, and this is 1. Okay, well, what I'm interested in is the region that's in between my two functions. So I'm interested in this yellow shaded region right here. Well, I've got part of what I need to set up my definite integral. I have it's going to be an integral. I'm going to think of upper, or the top, minus the lower. Okay, my upper function, look over here, is going to be, so again, my upper function is going to be the green function, which is just the horizontal line y equals 5. So we have 5 minus my lower function, which is my parabola, which is going to be x squared plus 1, and then dx. Now, I have everything I need except for my lower and my upper bounds. Okay, well, those are going to be my points of intersection between the two functions. Okay, well, the way I can find this algebraically is just to set the two equations equal to each other. I'm going to do that right over here. So my one function is x squared plus 1 equals, my other function is 5. And I'm just going to solve for x, subtract 1 from both sides. I get x squared equals 4. So I'm going to take square root of both sides. Square root of x squared is the absolute value of x is equal to, and radical 4 is equal to 2. So my answer is going to be x equals positive 2, x equals negative 2. Okay, so these two values, positive 2 and negative 2, are going to be my 2 and positive 2 are going to be my lower and upper bound on my integral. So my lower bound is -2, and my upper bound is +2. Okay? Okay, now, as I go to get ready to integrate this, I'm just going to do a rewrite. So I'm going to have the integral from -2 to 2. And if I factor, distribute the negative, this is 5 minus x squared minus 1 dx. And then if I combine like terms, 5 minus 1 is going to be 4. So that's going to be 4 minus x squared dx. Okay. Okay. Give myself a little room here. So if I continue my find the antiderivative, so this is going to be 4x, and I'm going to go down and over. So it's going to be 4x minus x to the third over 3 is my antiderivative, such that I bring my bounds over, -2 and 2. Then my next step is I'm going to drop in my upper bound. So 4 times 2 minus 2 cubed over 3 minus, and I'm going to drop in my lower bound. It's going to be 4 times -2 minus -2 cubed over 3. And that is my answer. Now, unfortunately, or fortunately, this is a multiple choice, and so I'm going to have to simplify this. So if I look at the left side here, I have 4 times 2 is 8, minus 2 cubed is 8, so minus 8/3. Okay, minus, I have this in parentheses, it's going to be -8, and that's going to be -2 cubed is 8, so it's going to be -8/3. So minus -8/3 is going to be plus 8/3. Okay, so if I distribute the negative here, again, I'm going to have 8 minus 8/3 plus 8 minus 8/3. So I'm going to get 16, the 8 and the 8, minus 16/3, which is going to be, if I rewrite 16 as a number over 3, that's going to be 48/3 minus 16/3. Looks like it's going to be 32/3, which is answer choice D. Okay. All right. Not too bad. Okay, the next one. What's the area of the region between the graphs y equals x squared, y equals -x from x equals 0 to x equals 2? All right, well, again, sketch might be the easiest way to go. So if I go ahead and just sketch this out, x and my y-axis, and I sketch y equals x squared. It's just a quadratic parabola. Just goes through the origin. Y equals -x. Okay, now that one, y equals -x, that's just going to go like that. So really, what I'm looking at is kind of this skinny part right here. That region right there is what I'm looking to find. Well, I can kind of tell one of those points of intersection is going to be at the origin. So I've got a point there at 0, 0. So that's one point of intersection. Then I got to find this other point of intersection. Then I can build my definite integral. Okay. So to do that, I'm going to do the same thing I just did. I'm going to set my two equations equal to each other. Do that down here. So my one is x squared is equal to -x. Okay. Now what I can do is I can add this x to the other side. So I'm going to have x squared plus x equals 0. And then I can factor an x out of this side. I'm going to get x times the quantity x plus 1 equals 0. And then if I look at that, that tells me that in order for this to be a true equation, x can be equal to 0. And that's what I got at that one point of intersection. Or x can be equal to -1. So that is where my other, that's the x coordinate of my other point of intersection. Okay, this point is as a coordinate next, x coordinate -1, and then whatever the y coordinate is. Actually, it's going to be +1, it looks like. Okay, but all we're interested in is just the x value. So those are going to be our lower and our upper bounds for our definite integral. Okay, so our definite integral, see if I can fit it all on this time. It's going to be the integral from -1 to 0. Okay, going from -1 to 0, integrating left to right. And I'm looking, my upper bound is the pink function, which is -x. So I want to put upper minus lower. Okay. So upper minus lower, and my lower function is minus x squared dx. Okay. Now I go to find my antiderivative. Antiderivative, my first term is going to be negative x squared over 2 minus x to the third over 3, such that upper bound is going to be 1, or I'm sorry, upper bound is 0, lower bound is -1. Okay. Now here's a case where when we plug in our upper bound, we're going to get 0. Minus, and then our lower bound, we're plugging in -1, is going to be -1 squared over 2 minus -1 cubed over 3. Okay. So now when I go to simplify this, because again, this is multiple choice, I have this negative, just rewrite this, have my negative sign outside the parentheses. And then I have, kind of working from inside out here, I have -1 squared is going to be 1, but then I have this negative, so that's going to be -1/2 minus -1 cubed is -1, so this is minus 1 -1/3. Okay, so if I have a negative, now this is going to be the same as negative. I'm going to just rewrite it as fractions over my common denominator of 6. So it's going to be -3/6. And then minus a -1/3. So that's going to be equivalent to plus 2/6. Okay. So if we add those together, we get the opposite of -1/6, which is going to be 1/6. Which, strangely enough, is not an answer choice. Okay, so let's kind of back up and see where we might have gone off the rails. Got y equals x squared, y equals -x, and we found our points of intersection. Should work out. That's 1, 1. And that would be also y equals -x, so that's 1 point, and the other would also be at 0, 0. So I think our lower and upper bounds look good. Our upper function is the -x minus lower function of x squared. So I think we've got our integrated set up correctly. Let's double check to see how we did our antiderivative. So -x squared over 2 minus x to the third over 3. Looks good. Brought over our lower and upper bound. plugged in our upper bound, gave us 0, minus our lower bound, plug that in. We have negative 1 squared over 2, minus negative 1 cubed over 3. Okay, I'm going to kind of lose this and just do from that part. Pretty sure we're good on that. So we've got negative, that's going to be negative 1/2 minus negative 1/3. And if I convert them both to just fractions over 6, I'm going to get the opposite of negative 3/6 plus 2/6 is equal to negative of negative 1/6. Huh. Okay, let's see. Okay. All right. Well, it's a good lesson for Mr. O'Sullivan to read the entire problem. So, graphed it correctly. We did find a bounded region, but I ignored what that told me right there. I was only interested in the area of the region between the graphs from x equals 0 to x equals 2. So really, kind of just do a restart on most of this stuff. So this tells us our lower and our upper bound. We want to go from 0 to 2. So actually, we're really interested in the area from there to there. Only from x equals 0 to x equals 2. Okay, well, let's try again. So we're going to have a definite integral. Lower bound will be 0, upper bound will be 2. Our upper function is going to be x squared minus our lower function, which is going to be negative x dx. Quick little rewrite from 0 to 2 of x squared plus x dx. Take the antiderivative, x to the third over 3 plus x squared over 2, such that lower bound, upper bound, plug in the upper bound, it's going to be 2 cubed over 3 plus 2 squared over 2 minus, plug in the lower bound, we're going to have 0. So then to simplify this, hopefully we get an answer that matches. We're going to get 2 cubed is 8, so that's going to be 8/3 plus 2 squared is 4 over 2 plus 2. So if I write that as 8/3 plus 6/3 equals 14/3. Yay! So that is answer choice D. Okay? Okay. Guys, I'm going to go back and I'm going to do this calculator problem right here, number 2. Okay? So what we're looking at is I've already put this in the calculator. So I put y1, this function here, and I put in my y2 in my calculator, x over 2. And so what I'm looking to do, I'm going to show you a graph of that. So if I use this, just so that we kind of see the graph. Okay, so kind of just draw on my graph here. I could say that the this top function, because what I'm interested in is going to be this region right here. Let's see if I can shade something that shows up. So it's going to be that region right there. And so I can see I have a point of intersection right there at 0. Equals 0, that's going to be my lower bound. Now what I have to find out is what that point of intersection is right there. Well, if I use the intersection function on my calculator, I'm going to find out that that is going to be equal to x equals 3.2. Okay, so that is going to be my upper bound. Okay, now I just have to make sure I know the top function, the upper function, is going to be this function right here, and that is my y1. The bottom function is going to be y2. Okay, so what I want to do is I'm going to set up this definite integral, and then I'm going to show you how to put it in the calculator. So the definite integral would be from lower bound of 0, upper bound of 3.2, and then it's the top minus the bottom. Top function is y1, bottom function is y2, and then my differential dx. Okay, and that's going to give me my answer. Okay, now I'm going to show you how you can do that in the calculator. Okay, and again, remember, I already have entered in my calculator, y1 is square root of 4x minus x squared, and y2 is x over 2. Okay, so here we go. Looking at the calculator, what I want to do is go to my home screen. So I'm going to quit out of my graph. So second quit, clear my home screen. Okay, and then what I want to do is I want to go to math, which is right below the alpha key, and I want to select option 9. Just arrow down. That's FNINT. Okay, and that's going to be my integral. So I select that, and now I get a kind of a template for a definite integral. Okay, so now what I'm going to do is I want to enter my lower bound, which is let's double check again. Lower bound is 0, upper bound is 3.2. So my lower bound is 0, and then I arrow up, and my upper bound is 3.2. Okay, and then I'm going to right arrow, and now to put my integrand in, I'm going to do, there's a couple ways you can get there, but I want to get to my y1 and my y2 functions. One way I can do it is I can go to alpha and then trace. And what that does is that brings up all my y functions. Okay, so again, it's y1 minus y2. Okay, let's double check. Yep, y1 minus y2. So make sure I had the order correct. Okay, so I'm going to do y1. I just select that, and that's what it's on right now. So enter, and then minus, and then I do that again, bring up alpha, and then trace, and I arrow down to y2 this time, and then hit enter. Okay, then I have to move right arrow again, right arrow, and then I need to put dx, my differential. Okay, then I'm going to hit enter, And the calculator is going to calculate my definite interval. Okay. There is my answer. Just select that. Just going to bring it in. And there, just so you have it, is how that was entered in the calculator. And so my answer looks like it is 2.82, and there it is, part B. Okay. All right, guys, I'm going to stop there. We've got a few example problems for you to come back and do. If you can see, if you can maybe get through up through maybe problem 7 or so, if you have some time to do that, and we'll take a look at that and go from there. And again, if we might be able to finish up the rest of all 14 of them by Monday morning. All right. Thanks, guys.